Now, if you could get into a time machine and travel back to 1969, you'd see something spectacular. What you're looking at isn't some random desert. It's one of the most powerful waterfalls, completely dry. In the summer and fall of 1969, the American side of Niagara Falls stayed without water. It lasted 6 months. Researchers wanted to study the rock face of the falls. They were afraid it was going to become too unstable because of erosion. Erosion is the process when natural forces, such as water and wind, wear away earthen materials. For example, if you see glacial ice become muddy, it means erosion is happening. 3 waterfalls that cross the international border between Canada and the United States together make something we know as the magnificent Niagara Falls. The 3 waterfalls are the Horseshoe Falls, the American Falls, and the Bridal Veil Falls, in order from largest to smallest. The American Falls are fully on the American side, while the Horseshoe Falls are primarily on the Canadian side, divided by Goat Island. The Bridal Veil Falls, the smallest of them all, are on the American side but separated from the others by Luna Island. Don't America and Canada have a cool natural border? Many didn't believe we could actually go against wild nature and stop such insane amounts of water from flowing. But we did it. It took a 600-foot dam across the enormous Niagara River to really shut down these astonishing falls. This means they had to divert 60,000 gallons of water every second so that the remaining flow traveled over the biggest Horseshoe Falls, the ones that are completely on the Canadian side of the border. Over 27,000 tons of rock were used to construct that dam, and more than 1,000 trucks carried that rock back in the hot summer of '69. On June 12th, the American Falls stopped after their continuous flow for more than 12,000 years. So the Horseshoe Falls then took the extra flow and absorbed it so that research could be done. But the locals were still worried. They knew it wasn't possible to control such amounts of water. They were afraid the water might take a different route and cause a catastrophic flood. They were worried that tourists wouldn't come anymore if teams didn't manage to make the waterfall flow again the way it used to. But tourists kept coming even that summer, and they got a unique chance to see something no one had ever seen before or after. During that period, there was even a temporary walkway built only 20 feet away from the edge of the now dry falls. It helped workers to clean the bottom of what used to be a river, so tourists could go there and explore the wild landscape of the falls that was usually under the water, hostile and not accessible to visitors at all. As they were exploring the dried bottom of the falls, researchers stumbled upon millions of different coins people had thrown in the water over decades, maybe to make a wish or for some other purpose. Wow, a Niagara Falls piggy bank! Well, they removed most of those coins. I wonder who got them. But in the past couple of decades, more and more tourists have been coming here. Imagine all the things they could find now. More coins, of course, but also lost cameras, errant drones, cell phones, and other things careless visitors could accidentally drop in the waterfalls. The idea of removing all the water and turning Niagara Falls into a desert proved to be possible, but it may need to be done again. In 2020, the media reported that 2 pedestrian bridges in Niagara Falls needed to be either replaced or repaired. No wonder, since they're almost 120 years old. These bridges are located above the rapids. Experts discuss whether they should divert the water once again or not. People talk about Niagara Falls a lot, and some believe they're among the tallest waterfalls in the world. But the truth is, they're not. They're famous, precious, and breathtaking. But when it comes to height, there are nearly 500 other waterfalls across the globe that are taller than Niagara. Let's take Angel Falls in Venezuela, for example. They're more than 3,000 feet tall. But what makes Niagara Falls so special, among other waterfalls, is the amount of water that flows over them. Very high waterfalls don't usually have great amounts of water. The combination of all those huge amounts of water and the height is what makes Niagara Falls so breathtaking. Also, they might be some of the fastest moving waterfalls on our planet. The Niagara River appeared after the last ice age, together with the whole Great Lakes basin. The Niagara River is part of it. 18,000 years ago, I wasn't around then, this awesome waterfall didn't exist. Ice sheets covered the area of southern Ontario. They were 1 to 2 miles thick. As the ice sheets were moving southward, they created the basin of the Great Lakes. Then they melted, releasing enormous amounts of water into the basins. Generally, the water we drink is fossil water. Only 1% of it renews through the year, with the remaining 99% coming from ice sheets. The Niagara Peninsula hasn't been beneath the ice for nearly 12,500 years. As the ice melted, the resulting water started to flow down through what later turned into Niagara River, Lake Erie, and Lake Ontario. It took a lot of time, but the water eventually eroded cliffs and formed these spectacular falls. Now, you might have noticed that the Niagara River is amazingly green. This specific color tells us how powerful the water is when it comes to erosion. Every minute, Niagara Falls spews over 60 tons of dissolved minerals. All that, together with dissolved salt and finely ground rock, makes the color so magnificent. People who live in the United States and Canada, or more precisely, over 1 million people who have access to the area, use the waters of Niagara River for different purposes. For example, fishing, getting drinking water, doing recreational activities, including swimming, boating, and birdwatching, producing hydroelectric power, and so much more. Now, the first hydroelectric generating station in the world was built at the end of the 19th century, and it was right next to the falls. Pretty soon it started paying off because people were getting electricity from it. But this electricity could travel only 300 feet, so something needed to be improved there. Nikola Tesla was the one who took up the challenge and made the necessary changes. He discovered that electricity could travel long distances if an alternating current was used. Today, several Niagara Falls power plants provide over 2 million kilowatts of power. Okay, I'll tell you another interesting thing. 1969 wasn't the only time when Niagara Falls stopped. Back in 1848, the water didn't flow over the falls for up to 40 hours. Now, the falls were already very popular among tourists and a useful source of energy for local people, so no wonder they freaked out. Nature was to blame this time. Ice blocked the source of the Niagara River. An American farmer was the first one to notice it. It was March 29th, and he went for a walk right before midnight. Soon, he realized he couldn't hear the powerful roar of the falls. He quickly went to the edge of the river and stood there in shock. There was hardly any water. Factories and mills had to shut down because they depended on that water. Turtles were just wandering around. Fish didn't survive. Some people took a walk on the river bottom, taking little things they could find there as souvenirs. But 2 days later, on March 31st, people heard a distant rumbling coming from upriver. It was getting nearer and louder until a wall of water appeared in front of their eyes. And one of the world's greatest attractions that millions of tourists visit every year was back in business again. Magnificent and, in the end, invincible. As it should be. So, some scientists drilled through the seafloor off the U.S. East Coast only to find more water. But this time, it's the kind of water we can actually drink. And that's a big deal, because this new freshwater reservoir could supply a metropolis the size of New York City for the next 800 years. Now, the team is confused. They're trying to figure out how a giant freshwater system ended up under the ocean, and, more importantly, how it stayed hidden from us for over 20,000 years. Okay, to be fair, scientists have suspected there's fresh water under the seafloor since the late 1960s. But only recently, researchers actually got on a boat to follow up on those reports. They named the mission Expedition 501, and they had one goal: drill to the bottom of the ocean and see what was really hiding down there. So those scientists drilled about 1,300 feet down off the coast of Massachusetts, and once they got that deep, they hit a thick layer of sediment that was basically soaked with fresh water. Now, that freshwater layer sat below the saltier sediment, and above it, there was a tight lid made of clay and silt, material that doesn't really let water pass through. This seal is strong enough to keep the two layers separated. So, up top, you got seawater, and down below, fresh water. The drilling process took about 3 months. In that time, they pulled up 13,200 gallons of water from 3 different spots beneath the seafloor, just off Nantucket and Martha's Vineyard. They're still analyzing the results, but early reports suggest this reservoir might be much bigger than they previously thought. It could stretch from offshore New Jersey all the way north to Maine. Now, despite its size, it did a pretty good job hiding from us. Now, scientists are trying to figure out when and how this reservoir was formed. And back in 2003, one study suggested fresh water could get trapped under the ocean in at least 3 different ways. Theory number 1. Tall mountains near the ocean can funnel rainwater straight down from higher elevations and into the seabed. Theory number 2. A hidden reservoir can form if sea levels stay very low for a long time and rainwater seeps into the ground. Then, when sea levels rise again over hundreds of thousands of years, that fresh water can get trapped in the sediment underneath. And theory number 3, which is connected to the one before, is that a freshwater reservoir can form under the ocean when ice sheets grow and sea levels drop. At the bottom of the ice sheet, the ice slides over solid rock, known as bedrock. As the ice scrapes and grinds against this rock, it creates heat, which melts some of the ice. That melted water collects at the base of the ice sheet. Then, because the ice is extremely heavy, it pushes the water down into the ground. Over time, the water gets trapped under layers of sediment. Well, more than 20 years later, scientists are finally close to an answer. The mountain theory is basically ruled out here because of the geography of New England. There are no large high mountain ranges right next to the coast. But the glacier theory could make sense. Their hypothesis is that the fresh water in this reservoir came from glaciers at some point during the last ice age, which lasted from about 2.6 million to 11,000 years ago. Still, it's not a final answer. The team is now studying the reservoir in much more detail. They're still analyzing things like microbes, rare earth elements, and the pore space in the sediment. All of that can help researchers estimate the reservoir's size more precisely. The age of the sediments can also narrow down when exactly it formed, and knowing its origin will help reveal how those systems have evolved over time. We just have to wait a little longer. But one thing is certain, there really is fresh water under the ocean. And when you think about that, it's hard not to wonder, wouldn't some salt get mixed in? And yeah, that can happen. So let's take a look at the map. Here's the reservoir. The farther you go from the coast, the saltier the water gets, and that doesn't matter much to us because it's not safe to drink anyway. But the closer you get to the coast, the less salt there is. The drill site closest to Nantucket and Martha's Vineyard showed that out of every 1,000 parts of water, only 1 part is salt, so it's considered safe. You can drink it, cook with it, and take a bath in it. But why does all of this actually matter? Well, because fresh water is becoming a big problem around the world. I mean, the lack of it. A new United Nations report talks about a global water bankruptcy. They say we've hit a new and pretty worrying stage. More and more river basins and underground water sources, called aquifers, can't go back to their historical normal. Droughts and shortages are becoming more permanent, completely changing what life looks like in some places. For example, the Aral Sea. This was once the world's 3rd largest lake and looked like this back in the 1980s. And this is how it looks today. It's completely dried out. It's not just there. More than half of the world's large lakes have lost water since the early 1990s. And Central Europe has lost 39% of its glacier ice in little over 20 years. So even now, over 1 billion people around the world still don't have access to fresh water. And estimates say that in just 5 years, demand will be 40% higher than supply. That's why this finding is such a huge deal. It doesn't mean we're about to start pumping water from under the ocean tomorrow. But it does mean we might have backup options in the future, especially for big coastal cities. That's exactly the goal of Expedition 501. And it's not just in the U.S. This group is part of a much larger international science program called the International Ocean Discovery Program, or IODP. Their goal is basically to drill deep into the seafloor to understand how Earth works, its climate, its geology, and in this case, its hidden water systems. This expedition came after decades of unanswered questions. Like we mentioned earlier, researchers had hints of fresh water under the seafloor for decades. Those hints came from strange electromagnetic signals and seismic data. But back then, the technology just wasn't good enough to confirm it. So the idea stayed on paper for a long time. Everything changed when modern drilling came into play. Expedition 501 literally drills straight down through the seafloor and pulls up sediment samples. And this process normally takes days to months. Is it safe, though? Well, they say the ship that carries the drilling rig follows international rules to protect the environment. They're also taking every precaution to make sure no solid or liquid material is dumped into the sea during the work. Their new finding off the East Coast is only the beginning. For now, it's the largest one of its kind. But scientists believe there may be still many hidden reservoirs out there around the world. Similar expeditions are planned or already happening near other parts of the world. Soon, scientists might find new reservoirs off the coasts of Indonesia, Australia, and even South Africa. So, Expedition 501 is basically about mapping these hidden freshwater reservoirs and finding out how they form, how stable they are, and whether we can protect them. Because, yeah, they still have a huge technical problem ahead, which is making sure the fresh water doesn't mix with the salty water above and below it. And that really matters if we ever want to use this water in the future, or avoid contaminating aquifers that already exist near the coast. So this expedition is pushing scientists to find answers to a pretty uncomfortable question. If fresh water gets harder and harder to find, what options do we really have left? Over 1,500 people lost their lives in this part of the ocean, so maybe it's a prudent idea to stay away from it. The spot where RMS Titanic sank remains dangerous. I mean, yeah, there are still huge icebergs out there, but there are even bigger threats lurking beneath the surface. Titanic is sitting about 12,500 feet underwater, nearly 400 miles southeast of Newfoundland. It's been down there for over 100 years. So, over time, the wreck's just been falling apart little by little. The infamous ship is rusting just like any iron or steel structure would be underwater. Chemically, when you mix iron, oxygen, and water, that combo sets off a reaction that creates iron oxide, and that's what leads to corrosion. So, steel plates, beams, all that stuff is getting weaker. Parts of the liner are caving in, like the ceiling in the captain's bathroom and a section of the railing that collapsed not too long ago. But in the case of Titanic, a lot of that corrosion is actually being caused by iron-eating bacteria. When the Titanic sank, it split into two big pieces, the bow and the stern, which landed nearly 2,000 feet apart on the ocean floor. And now both pieces are covered in this biofilm, a living blanket of bacteria, marine fungi, and all sorts of other microbes. Over time, microbes feeding on the ship's iron have created these things called Rusticles, and they are actually speeding up the wreck's decay. Scientists say the stern is breaking down way faster than the bow, mostly because it took more damage when the ship sank. And now, thanks to all that bacterial activity, the stern could be deteriorating as much as 40 years ahead of the bow. So yeah, microbes have been thriving and flourishing down there. If you are a germaphobe, that probably sounds like a total nightmare. But honestly, it's not that bad. For one, they don't even look gross. These rusticles actually look kind of cool, like ice crystals or tiny diamonds clinging to the wreck. And don't worry, you are not in danger. As long as you keep a safe distance from the wreck, no direct contact, and definitely don't go poking around inside, there really is no risk. Speaking of getting dangerously close, we've got to mention the Titan submersible disaster. You know, the one that catastrophically imploded back in 2023 during a trip to the Titanic wreck. Sadly, all 5 people on board lost their lives. Even though this trip was sold as a tourist adventure, going that deep in the ocean is no joke. It's terrifying, cold, and dark. Sunlight gets absorbed by water and can't reach much farther than about 3,300 feet below the surface. Past that point, The ocean is in total darkness all the time. Titanic lies within a region known as the Midnight Zone for this very reason. The few brave people who have visited the wreck say the descent takes over 2 hours through complete darkness. Then, out of nowhere, the ocean floor just pops into view, lit up by the submersible's lights. The second big challenge is actually finding the wreck. At that depth, navigating is no easy task. When you reach the bottom, you really don't know exactly where you are. You're just kind of fumbling around in the dark, knowing that Titanic is somewhere down there, but you can't see it. However, detailed maps of the Titanic site, made from decades of high-res scans, really do help. As the wreck starts to come into view, they can use those maps to stay on track. Plus, sonar and sensors let the crew notice features and objects even if they're way beyond the sub's tiny light pool. For example, the Titan submersible had a sensor called the Doppler velocity log. This one sent out sound waves to measure how fast the sub is moving and how deep it is, based on its distance from the ocean floor. Still, passengers on previous trips to Titanic in this submersible have said how tough it is to find their way once they reach the ocean floor. And we can't forget about the pressure. The deeper you go in the ocean, the more pressure the water puts on everything. And the pressure is crazy high at the Titanic's wreck site. To put it into perspective, it is about 200 times the pressure inside a car tire. That's why submersibles need super thick walls to handle it. So yeah, the water around Titanic has creepy microbes, pitch-black darkness, and insane pressure. But there is one more thing happening down there, and that's unpredictable currents. You're familiar with them. I mean, when you swim in the sea, you can usually feel the currents pulling you from side to side. But the deep ocean has its own set of underwater currents too. They're not as strong as the ones you feel on the surface, but they can still move massive amounts of water around. These currents can be caused by things like wind, differences in water temperature and salt, and even strange storms down on the ocean floor called benthic storms. They can get intense and stir up the sea bottom. Now, like I mentioned earlier, the Titanic wreck is in two big pieces, the front and the back, and researchers have been checking out the seabed of the surrounding area. One part of the wreck is near this cold underwater current called the Western Boundary Undercurrent. It flows south and moves mud and sand along the ocean floor, creating ripples and patterns that show how strong or weak the current is. Most of the time, the currents there aren't very strong. They even found sand ripples near where all the Titanic debris landed, like furniture, coal, and just random stuff from the ship. And those ripples are showing a current flowing from east to west. But inside the main wreck site, things get a little wilder. The water flows more from northwest to southwest, probably because all the huge chunks of the ship are messing with the flow. Around the south side of Titanic's bow, the currents get unpredictable too. They keep switching directions, from northeast to northwest to even southwest. It's like the ocean's just doing its own thing down there. Experts think that over time, all this shifting water is going to slowly bury Titanic under layers of mud and sand. Little by little, the wreck could just fade away and disappear beneath the ocean floor. Alright, now it's time to get to the obvious issue here – icebergs. Yep, they're still a problem for ships today. In 2023, around 380 icebergs flowed into the busy shipping routes between North America and Europe. That's a problem. You see, the bigger the iceberg, the easier it is to spot and avoid. Smaller ice is a lot harder to detect, though it's no less dangerous. And that's because the most dangerous part is underwater, where no one can see it. Think about the iceberg that sank Titanic. Passengers saw about 100 feet of it above the water, but it's believed that's only 16% of its total size. Experts say the rest, hidden beneath the waves and much larger than what's visible, could stretch down several hundred feet. Now, the good news is that, unlike Titanic's day, we have much more technology now to spot icebergs in time. Modern ships have radar and satellite imagery that can pick up icy threats hiding in the dark. Some vessels even use sonar and thermal imaging to see through fog, helping the crew to spot icebergs above the surface. GPS and AIS pick safer routes, and monitoring centers around the globe send out real-time alerts, like having a personal iceberg spotting assistant. So, yes, it is a massive upgrade from just relying on binoculars. You won't have to worry about icebergs on your next cruise vacation, even if it passes alongside Titanic's route. But just to be extra safe, try not to travel with anyone named Jack or Rose, and never play the violin while on board. Just saying. Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and it's called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, it may be too late for that, but I'll try. The ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please.
See this big spot under the water near the shore? It's a coral reef. It beckons you to swim closer, but be careful. If you get there, it could be the last swim of your life. Stay away from the reef. But why? Why are coral reefs so dangerous? Let's figure it out. First, make your guess about what a coral reef is. An underwater cliff? Rocks? A coastal landscape? Some spot where shells live? Close, but not true. In short, a coral reef is a living thing. What we see in shallow tropical waters are colonies of organisms called coral polyps. They are distant relatives of jellyfish and anemones with amazing superpowers. They can absorb calcium from the water. When they do this, they convert calcium into hard limestone rocks. These rocks, like building blocks, form solid coral reefs and settle on the seabed. But there are soft coral reefs that look like plants. They float freely with the currents, swing in different directions, and seem to pulsate under the water. They don't have solid coral blocks, but they can grow tree-like cores to maintain their position. Both hard and soft coral reefs are beautiful creatures, but at the same time, they are very dangerous. Many ships were wrecked when they hit shallow water, as the sharp edges of coral reefs ripped through their hulls. But what danger is there for someone swimming alone, who isn't going to hit the reef? You can just scuba dive and enjoy the beautiful views of coral polyps, but be prepared to encounter unexpected and unpleasant creatures. A coral reef is not just a living colony, it's a home for thousands of diverse marine creatures. And some of them can be very dangerous for humans. Like the blue-ringed octopus, for example. This is a tiny creature that you will definitely notice thanks to the bright spots on its body, but don't touch it with your hand, as it's one of the most venomous creatures on Earth. The amount of toxic venom carried by this octopus can harm 26 people, and these people are unlikely to survive this encounter. The poison works within a few minutes, and there's no antidote in the world. What makes it even more dangerous is that the octopus's sting is painless. You probably won't even know you've been stung until the first symptoms appear: body paralysis, respiratory problems, and cardiac arrest. But even if you don't notice the octopus and swim past, you'll probably notice the box jellyfish, whose tentacles can reach several feet in length. It looks like a creature from deep space, and you better not approach it. The box jellyfish is considered the world's most venomous creature. There are special cells in their tentacles that release a toxin called nematocysts. Over the past 100 years, roughly 70 people lost their lives after encountering these jellyfish. But most likely the number is much higher. We just don't know about all such cases. Unlike the painless sting of the blue-ringed octopus, the encounter with a box jellyfish hurts. Another dangerous inhabitant of coral reefs is a rock. Yes, take a look. It's just a rock that's part of the reef. But wait a minute, it seems to be moving. Don't touch it. It's incredibly venomous. By now, you've probably already realized that this is not a stone. This is the stonefish. And this sullen-looking guy is one of the most venomous fish on the planet. Do you see those little spikes along its spine? The fish raises them when it feels in danger. If the toxin covering these spikes enters your body, you have less than an hour to take the antidote. If you don't make it in time, better not dwell on the worst-case scenario. Do you still want to swim closer to the coral reef? If so, go ahead. There are other scary creatures there. This one, for example, doesn't pretend to be a rock or something harmless. It looks dangerous, and it is dangerous. It's the moray eel. These underwater snakes are not venomous, but meeting them can be unpleasant. They can bite quite painfully, but only if you disturb them in their burrows. Of course, you probably won't want to tease these creatures, but you might accidentally approach their burrow without knowing they live there and poke it with your finger. Once you do it, get ready for a payback strike. By the way, moray eels are poisonous because they eat toxic algae and fish. However, they can't use this poison against you unless you try to eat them. As you approach the coral reef, you may encounter a flying dagger. This is the needlefish, a thin, fast fish with a sharp nose and prickly needle-like teeth. It swims near the surface close to coral reefs at high speed and then jumps out of the water and flies at a speed of 37 miles per hour. Many people have reported getting seriously injured by this guy. This one looks like barbed wire shaped like a star. Hundreds of sharp needles cover the crown-of-thorns starfish's body, and you'd better not touch them. Each thorn on their body contains dangerous toxins that cause pain, nausea, swelling, and can even lead to anaphylactic shock. Coral reefs are not just a place for them to hang out, but also food. This starfish bulges out its stomach, covers the reef surface with it, and absorbs nutrients from it. It's like something straight out of a sci-fi horror movie. But don't think that corals are something scary and dangerous. In fact, coral reefs are some of the most useful things in the ocean. They even save people's lives. Do you know that lines of coral reefs cushion the impact of tsunamis and protect the shores from flooding? Some large reefs, like the Great Barrier Reef, are the boundary between the open sea and shallow waters. They stretch along the coast and form a protective wall that serves as a barrier against tsunamis and landslides. During a storm, rocky coral reefs disperse large waves and soften their impacts on the shore. But the coolest thing is that corals help your Instagram profile look better. What? Yes, that's right. Do you know these beautiful paradise-style photos when the water near the shore is blue and the sand on the beach is white? So sand gets this unique color thanks to corals. As you already know, coral bodies are made up of calcium carbonate. When waves and storms destroy corals, they wash out these calcium particles directly onto the shore. Besides corals, tiny bits of crushed seashells also end up there. Over time, layer by layer, they build up to form white sandy beaches. By the way, parrotfish are also involved in creating this beauty. These little fish feed on algae that stick to coral reefs, so they also consume pieces of coral along with their food. Then, when they're full, they release the coral particles, which eventually become the white sand. One such fish releases about 200 pounds of coral waste per year. So in a sense, this white sand appears because parrotfish go number 2. Coral reefs are ancient. The average reef grows at a rate of about 0.7 inches per year. And now look at their sizes. The Great Barrier Reef stretches for more than 1,430 miles, and it's been growing for 8,000 years. It's been here since people began to develop agriculture, domesticate animals, and build the first settlements. And some reefs are much, much older. That's why it's so important to preserve this unique natural wonder. And humans end up destroying it, often when ships accidentally crash into coral reefs. When this happens, it ruins the home for thousands of sea creatures. Ocean ecosystems get majorly impacted. But we also try to improve the situation. Coast guards protect the areas where coral reefs grow so that no vessel can approach them. These majestic creatures are a crucial part of nature, and this is another equally important reason why we should stay away from them.
Ooh, you're diving into the dark and icy waters of Antarctica. The eerie blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it Bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well. off the western coast of Australia and near New Zealand. They recorded similar but higher pitch signals, which they named Biogoose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on Bioduck and Biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the Bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The Biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike Bioduck, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales. specifically bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the Bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound source was a giant sea monster, kraken, or some other creature. The hype around the Bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the Bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet Upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it. It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nader crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high. almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nader crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years, because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nader asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground. And still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event, this time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA's keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700, but still, it's a reminder that Earth is always in the cosmic firing line.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke two seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh? Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn. Going to the beach in winter seems like a good plan. You can have a bonfire, build a sandcastle, search for shells, or swim in the ocean. The vibe might make you overlook the dangers ahead of you. Do you really think through the potential risks of paying a visit to the beach in the winter? The number one risk is waves. You might think it's okay to admire the view on the beach a few steps back from the ocean. Now let me introduce you to sneakers. Not the chocolate bar, sneaker, or with another name, sleeper waves. These are oversized coastal waves. They catch people off guard because they occur without warning or trace. These waves are particularly seen in Oregon, United States. People have been injured and at least 17 people have been swept up into the ocean since 2000. It got more media attention in 2011 when a memorial statue was built honoring the two teens faced with sneaker waves in Oregon. So, how come these waves are so dangerous? It's about their nature. They come out of the blue. With big waves, you see them coming or growing big. Plus, they form in the ocean and come towards the beach. These waves appear near the shore. It leaves less time for you to run to a safer spot. Okay, most of the time, they're not huge, as would be seen in apocalyptic movies. Yet, you can never know what nature holds. Maybe you remember this example from Mavericks. In 2010, a crowd was watching the surfing competition. Suddenly, two large waves struck the people on the beach. It broke the seawall and injured more than 10 people. Sneaker waves don't look particularly larger than other waves until they break and quickly reach the beach. They form in a period of 10 to 20 minutes in between soft and regular-sized waves. They can surge more than 150 feet beyond the foam line. Then they reach the land with high power. Plus, they carry lots of sand and gravel with them. Sleeper waves are more commonly seen along steep coastlines compared to beaches with wider and softly sloped areas. People named these waves, not scientists. They observed what waves do. They washed up in a sneaky way. I mean, scientists didn't classify this phenomenon as a distinct sort of wave like they did with tsunamis or rogue waves. There's little scientific research made about them. Researchers say that sneaker waves form in offshore storms. These storms transfer the wind energy to the water surface. The waves carry this energy and then arrive at the beach during times of calm weather. The larger amount of energy they obtain compared to the regular waves that preceded them causes them to go higher up the coast. Imagine you go for a walk on the beach with your dog. The waves gently reach the beach. You play the throw and catch game. You don't know about sneaky waves, so you turn into an unwary beachgoer. What's the risk? Being washed into the water trapped against rocks. Since it's winter, you tend to wear heavier clothes. The sand that sneaker waves carry can quickly fill clothing and shoes, and that weighs you down. How can people enjoy the beach safely? First off, keep your distance if you're on the beach for storm watching, for instance. It might be mesmerizing to see how waves roll in over miles of ocean. The storms hit the shore, and you look at those extreme turbulent swells transform into strong 30-foot long waves. Finding a higher spot that sees the ocean and waves might be best. Be the eagle, not the crab. Did Confucius say that? The second tip is if you're determined to storm watch, never turn your back to the ocean. Yes, eyes on the water. Lastly, be mindful of which part of the beach you're walking on. Stay away from the logs because they hold water. The water increases their weight. In the worst-case scenario, the ocean is powerful enough to roll the logs onto you. Let's assume you're hiking near the ocean. Use the designated trails because park authorities determine them as the safest roads possible. Going off-route can sound charming, but it can be dangerous for you and harmful to the ecosystem in the surrounding area. Now that you know where to walk, you can keep your eyes open about the geological stuff. Like the rocks can be slippery, erosion can rip them off. Yeah, it's better to avoid walking near bases of cliffs and bluffs. You'll never know when a natural phenomenon will occur. It might sound a little extreme, but you may want to check the tsunami evacuation routes of the area you're visiting. Tsunamis are hard to predict, but tides aren't. Tide tables are available online. This natural phenomenon looks harmless, yet it can isolate rocks from headlands and the shore. You probably don't want to find yourself with soaked wet clothes in the ocean for no reason. Climbing up onto the logs might not be the best idea either. Sure, they look heavy and sturdy when you're climbing, but even the smallest wave can take you like a leaf flying in the air. Not just logs, but also jetties are tricky. Sudden waves can make you lose your balance, and you can collapse. Let's return to the scenario where you and your dog are walking on the beach. This time your pet sees shorebirds and chases them. Birds could be there for foraging or roosting. Your dog could interrupt their chill zone. They can lose their energy reserves. Can you bump into creatures hiding under the sand? Some sorts of creatures can be dangerous for you. Better not to poke someone's home. Take a look at this one. It's a horseshoe crab. This one looks scary, yeah, but it's safe as long as you don't step on its spines. So it depends on the type of creature you see, but generally, it's okay to explore the sand with caution. Until now, we look at scenarios where you were on the beach when they caught up to sneaker waves. You could be in the water too. You could be surfing, just like the contestant in the Maverick surf competition, or swimming, if swimming is the new case. Consider these. The temperature is lower, the waves are crazier, and there are probably no lifeguards there watching you in the winter. Swimming with friends is a safe option. Bonus, it's more fun. You should choose your swimming location carefully. Are there dangerous rocky areas? Can you easily go out if there's some sort of emergency? Know your spot. For that, you should check the weather too. Planning has a key role in winter water safety. A quick weather forecast and sea conditions check would do. You can consider buying a tow float if you're an adventurous open water swimmer. It's a flotation device designed to increase the swimmer's visibility in the water. They are lightweight and have fluorescent colors. Alternatively, you can wear a brightly colored swimming cap. We can talk more about the gear. Wearing a wetsuit is wise, as well as wetsuit gloves and boots. You can put your phone in a waterproof pouch or bag. Staying warm is essential in the winter. Don't just jump into the water at once. This can result in cold water shock. It's vital to enter the water slowly. In that way, your body can get used to the temperature. Once you take all the necessary precautions, you can enjoy the beach and explore its offers. What sort of gems can you find on the beach? A mermaid's purse? Maybe. No, it's not the purse of Ariel from Disney's Little Mermaid. That's actually an egg case belonging to sharks and rays. It's made out of keratin, kinda similar to your hair and fingernails. These purses are the place where the embryo grows. The egg hatches and the cases are carried away with the water to the beach. If you want to find one, you can look at the area near the seaweed. Have fun while searching for it! Now, I'm ending this video with a quick joke that's suitable for the cold weather of winter. What did the ocean say to the beach? Nothing. It just waved.